Welcome to Electro Power Academy. Nkuko mumaze kubimenyera rero, this platform idufasha kubasha gukosora national exams zagiye zikorwa mu myaka yatambutse from primary 6 up to A level kuri TVET no kuri general education. Today we are going to correct chemistry done in year 2023-2024 chemistry national exam for this year for A level. Let's start from the question number 1. Question number 1, it gives the term corresponding with each of the following definition or statement. For number 8, atom of the same element with the same atomic number or number of proton, but with different mass number or number of neutron. Here it is isotope. Remember, for isotope, atoms have the same number of proton, but differ from number of neutron, which lead to different of number of mass number, because mass number equal to number of neutron plus number of proton, which is atom mass number. If there is same proton, but different neutron, this results with different mass number. Those atoms are called isotope. For number B, a device or instrument used to separate positively gaseous atom and molecule according to their mass to charge ratio and that record the resulting mass spectrum. This instrument is mass spectrometer. As you know, mass spectrometer helps us to differentiate either molecule or atom, but according to their positive gaseous, because first mass spectrometer change the molecule to gaseous ion. That's why this is a mass spectrometer. For number C, the term used to indicate the positive of an element in the periodic table or to refer to the number of protons present in atomic nuclei, it is atomic number. Remember, atomic number equal to the number of proton that or positively charged present in the atomic nuclei. For number D, a subatomic particle which is electrically neutral. Those particles are neutron. Neutron. Remember, for an atom, we have in the nucleus we have a neutron and the proton. For neutral particle, those are called neutron. Let's move to question number 2. For question number 2, state whether each of the following statement is true or false. The alignment of atom in graphite structure is called hexagonal. This is true. Remember, for graphite have hexagonal structure where there is the localized electron which allow this graphite to conduct electricity. For number B, consider the stability of group 4 element. Lead 2 oxide is more stable than lead 4 oxide. Exactly. This is true. because you know for group 4 element, oxide with oxidation number of 2 are more stable than oxide with oxidation number of 4, considering for lead, for even other element from group 4 down from carbon to lead. Also, this is true. Even here, this is true. Let's move to the next. In diamond structure, there are delocalized electrons. This is false. Remember, in diamond, we don't have delocalized electron, as diamond cannot conduct electricity. Number D, lead 4 chlorides decompose lead 3 without heating to form lead to chloride and chlorine gas. This is true. Remember, for this lead 4 chlorides, it can decompose easily to give this lead to chloride and chlorine gas, depending on its ionization energy. This is also true. Let's move to the next question. This is question number 3. The best answer among the alternatives given. A. According to Arrhenius, as the base theory, a base is defined as any substance acting as proton acceptor, any substance acting as proton donor, any substance which dissociates in aqueous solution to produce hydride as the only negative ion, any substance that dissociates in aqueous solution to produce hydroxide ion as the only negative ion. The correct answer is I. Any substance acting as proton acceptor. Remember, according to Arrhenius, acid it's like an acid. It is an electron deficient. It is missing irregular electron. It has where it can accept proton from another substance. That's why the correct answer is I. For number B, in any solution, in the following chemical equation, copper 2+ ion are acting as I, Bronsted Lowry acid, I, Arrhenius base, I, Lewis acid, IV, a Bronsted Lowry base. For this question, the correct answer is I, Bronsted Lowry acid. Remember, for Bronsted Lowry acid, it is an acid, it is a substance which can donate proton. Here, this copper can donate those 2 electrons. That is why the correct answer is I. For number C, which species among the following is more likely to act as amphibiotic or amphiprotic or amphoteric? For when you say amphoteric or amphiprotic, it is just a substance which can both donate and accept proton. Among those molecule given or element ion given, those ion given, a substance which can both accept proton and donate proton, it is HS-, because this HS- can donate H+ to produce. It can donate HS- can donate H+ to produce S2-. It can also accept H+. This can accept, donate, can this H minus can accept H plus to produce H2S. That's why it is in an amphoteric. It can both donate and accept proton. Let's move to the next. For question number D, the conjugate acid for phosphate ion is A, H3PO4, HPO4 2 minus, H2PO4 minus, H3PO4 minus. The correct answer here is triple E, because for conjugate of this phosphorus ion to be conjugated, it will gain H plus. It will gain H plus. Upon gaining H plus, the conjugate will become like this as final reaction. Let's move to the next question. Filling the blank with the appropriate term as provided here. We have half reaction, we have oxidizing agent, we have oxidation state and disproportionation. Dash is a substance or chemical space containing the element or species that accept electron, allowing another element or species to be oxidized. This is oxidizing agent. Remember, oxidizing agents ni substance yatumye indi substance iba oxidized. That is niyo twita oxidizing agent. Here we fill in oxidizing agent. For number B, dash is redox reaction where element in a molecule or chemical species is simultaneously oxidized and reduced. In a redox reaction, we have element which can be oxidized and element which can be reduced. That's why here we can put, among those, we can put oxidation state. At oxidation state, it is where we have element which already oxidized and element which already reduced. Here we have oxidation state. For number C, when balancing oxidation reduction, Ariotwita redox reaction, it is required to sum up the two half reaction. Remember, in redox reaction, we have two half reaction. After adding those two reactions, one which take place at cathode, another which take place at anode, then as the final equation, we add on those two half reaction. Half reaction. For number D, the dash is the total number of electrons lost or gained by an atom of element in a chemical combination. Here we can fill in disproportionation. Remember, when we are balancing redox reaction, there is a species which lost electron and one which gain electron. But after balancing chemical equation, then we sum up the number of electron either lost or either gained. That's why here we can fill in disproportionation. Let us move to the next question. Question number 5. Below are shown some alcohol compounds and some of their Their uses. Match each compound in column R with its corresponding use in column R. Column R, a propanol. We have A, propanol, we have B, ethanol, C, methanol, D, propane, 2-O. About uses. Use of propane 1-O. This propane 1-O can be used as solvent for resin and glycols. This propane 1-O also used in manufacture of propanoic acid. During preparation of propanoic acid, we may use propane 1-O, making pasteurizer. For ethanol, ethanol can be used. This means that A can be matched with. Here we have 1. Here we have 2. Here we have 3. Here we have 4. Then it can be matched with 4. For ethanol, this ethanol can be used as a biofuel. It also can be used for solving paints. It is a good solvent for paints and the varnishes. Also, this ethanol used during manufacture of alcoholic drink. Ethanol ishobora kwifashishwa mu gihe bari gukora anoma alcohol tubasha kunywa. Methanol means that ethanol for number B can be matched with 2. We have also methanol. This methanol, while we are preparing for a hydrant, we can use methanol. This methanol can be used as manufacture of formaldehyde, in manufacture of dyes, and manufacture of plastics in industry. This means C can be matched with S. For D, we have propane 2-O. We know where propane 2-O differ from propane 1-O. This functional group of alcohol attached on the second carbon, while here it is attached from the first carbon. This propane 2-O can be used for solvent for oil. It is a good solvent for oil. It is also used in synthesis of acetone. Also, it is used in the manufacture of antiseptic solution. When you say about antiseptic solution, are those solutions which can be used to prevent bacteria, to prevent infection. Means it can be used, those antiseptic solution can be used in cleaning or in health. Means this can be matched with number 3. Choose the best answer. Let's move to question number 6. Choose the best answer among the alternative given. In titration, 2 solution titrant and analyte are involved. The equivalence point occur when the number equivalent point occur when number of equivalent for the titrant solution become no. Number E, analyte solution become colorless. This is not correct. For number 3, titrant solution become colorless. This is not also correct. For number 4, numbers of equivalent for the 2 solutions become equal. This is the correct statement. Remember, for titration, at the end point or at equivalent point, number of titrant is equal to the number of analyte. Then let's move to the next question. Number 7. Nuclear chemistry deal with reactions that happen inside atoms. Define the term radioactive isotope. A radioactive isotope, it is unstable nuclear which can decay during after decaying, it emits radiation. It is just an unstable, which decay emitting radiation. Means during decaying, it can emit those radiation. Number B, state any one property of alpha particles. Among the property of alpha particles, we may say that they are positively alpha particles are positively charged. Also, those alpha particles, they have low penetrating power, up to only 10 centimeter. Also, those alpha particles, they have this up to 10 centimeter, and so on. For number C, a radioactive isotope of thorium element, which is symbolized chemically as this. It has atomic mass, which is 232, and the atomic number, which is 19. Decay according to the following scheme. We have this, then alpha particle emission, it produces X, then this X emits beta particle, then it produces Y, then this Y emits beta particle, produce element Z. Here, for alpha particle emission, when it emits alpha particle, when an element emits alpha particle, it rose two protons and two neutrons. For this thorium, which emits alpha particle for the first emission, means that these two protons should be released from this atomic number, and this neutron should also be released for atomic number, where we will get thorium 232. Here it will lost two proton and two neutron. Those protons also will be lost here from the atomic number. Lost two proton. We will remain with X, which has here 2 plus 2 equal 4. Then here we remain with X with 288 as atomic mass. Here it will lose proton, 2 proton, where we will remain with 88 as mass, as atomic number. Then this X also will emit beta particle. When an element emits beta particle, it gain electron. Where for beta particle, it should have X with any number. This X will be S. Then it will gain 1 electron. This electron should be added to the number of atomic number. Here we have a Y with D. This D will be, while for atomic mass will remain, because no neutron gained or lost will remain with 28889. Then emitting also here is beta particle. Emitting another beta particle. Here will emission. Here we will have Z. Also because it is a beta particle, also one electron will be gained. We will have Z with 288 and the atomic number which is 990. This means that atomic number of A tumaze kubona ko equal 288, B equal 288, C equal to D equal to 89 and E should be equal to 90. Is equal to 88. D equal to 288 C 89. Then E equal to. This is how this decay should be of thorium should be like. Considering those atomic number, you may identify what element is X, what element is Y, and what element is Z. Refer to those atomic number and consider those elements on the periodic table. Then let's move to the next question. Question number B. A specialized analytical use of acid-base titration to determine the concentration of a basic, which is also called alkaline solution, is known as acidimetry, double I, alkalimetry, colorimetry, spectrometry. The correct answer is alkalimetry. Remember, when we are conducting titration, this titration, during this titration, the one which is in conical flask is one which has an unknown concentration. Niba ifite concentration tutazi nitwa dushaka kujya gushakira concentration irimo rero niba ari basic ubwo tuzayita ari alkalimetry. The correct answer is double I. For question number C, potassium manganate kimonocate is commonly used to determine the concentration of aqueous iron 2 ions, which it oxidizes to iron 3 ion in the acidic medium. The most suitable acid for acidifying the reaction medium in this titration is nitric acid, since it is a powerful oxidizing and can react. This is not correct because this should not be reacting with this different iron. For number 2, hydrochloric acid, since it is oxidized to chlorine gas during reaction. Iki nacyo ntabwo ari cyo ko ntabwo dukeneye ko yo oxidizing kuriya oxidizing itangira chlorine, aho kugira ngo idufashe muri determining a concentration. For number 3, sulfuric acid, since it is neither oxidized nor reduced during the reaction. This is the correct answer. This sulfuric acid can neither have cyangwa be reduced during this reaction. Within a reaction taking place. The sulfuric acid, since they cannot provide the concentration of H plus ion, this is incorrect. The correct answer is in number 3, is sulfuric acid. For question number D, in order to be suitable in use as primary standard, a compound must have the following property except readily available and inexpensive. For primary standard, zigomba kuba ziboneka byoroshye kandi nanone zidahenze ko niba arizo dufasha gukora preparation yandi product, urumva dukeneye kuba product ikunda kuboneka kandi idahenze. Very pure analytical reagent grade about 99.9% purity. Ni ukuvuga ngo igomba kuba iri pure nyine, igomba kuba iri pure ku buryo nta impurities ziba zirimo. Kuri number 3, insoluble in the solvent used and under the condition used. This is the one which is not the correct property of primary standard, because this primary standard should be soluble so that it can be mixed with the solution you are preparing. Unaltered in air during weigh. This is the property of primary standard, because in a primary standard igomba kuguma kuri state yayo mu gihe igomba kuguma kuri initial state, nagomba guchenga initial state. Niyo mpamvu inariyo property niyo itari property ya primary standard. Let us move on to the next question. For question number 8, copper is mainly extracted from chalcopyrite, which is copper, iron, disulfide, in a 3-stage process. In the first stage, chalcopyrite is heated with silicon dioxide and oxygen according to the following equation. This is the equation of chalcopyrite, where it was heated with silicon dioxide and oxygen to produce this product. In the second stage, the copper sulfide is reacted with oxygen at high temperature, giving copper 2 oxide and sulfur dioxide. In the third stage, the copper 2 oxide is reduced by heating it with carbon. Question number 8. Write the balanced chemical equation occur at the second stage. Now we are going to write tugiye kwandika ese nihe reaction yabaye kuri second stage. Kuri second stage bari kutubwira ko for second stage, this copper 2 sulfide, which is this one, is roasted with oxygen at high temperature. This copper is roasted with oxygen at high temperature. Is even oxygen at high temperature to produce copper 2 oxide and sulfur dioxide. This will give us copper 2 oxide plus sulfur dioxide. Then we should balance this equation. To balance this equation, here we have 2 copper, while here we have 1 copper. If we put these 2, putting 2 here, we have 2 copper and 2 copper in the product. We have also 2 oxygen. Here we have 2 oxygen, but here we have 4 oxygen. 2 oxygen plus 2 oxygen means 4. We may put 4 here, 2 here. Putting 2 here, we may have 4 oxygen, and here we have 4 oxygen. 1 sulfur. Then our equation is well balanced. For number 2, we need to write chemical equation at third stage. Kuri stage ya gatatu batubwiye ko copper 2 oxide, ya copper 2 oxide yabaye produced kuri second stage is reduced by heating it with carbon. This copper oxide yabaye produced, copper oxide, then is reduced by heating it with carbon. This will give us copper plus carbon monoxide. Let's check if our equation is well balanced. We have 1 copper in reactant, 1 copper in product, oxygen, then carbon. It is well balanced question. So let's move to the next sub question. For number B, give anyone use of copper. Dukunda kubyumva ko tukabona nk'insinga z'amashanyarazi tukavuga ngo zikoze muri copper. This means that copper can be used as electrical wiring. For number C, explain any one environmental and one health-related problem that could be caused by copper extraction activity. Remember, for while we was extracting copper, there was a production of SO2, sulfur dioxide. This sulfur dioxide can be emitted mu kirere, then ikaba yabasha producing acid rain. For the environmental, SO2 produced can be emitted in atmosphere and produce and cause acid rain. Why for health related problem? For also during extraction there was a production of copper. That copper dust, it can cause some respiration problem. Okay, let's move to the question number 9. A student used to set up in figure 1 below to electrolyze the concentrated aqueous sodium chloride NaClO with carbon electrode. State the gas given off at the cathode. Nukuvuga ngo n'umunyeshuri yagiye gukora electrolyze ya aqueous sodium chloride ariko akoresheje zino electrode zikoze muri carbon. Then for question number A, they are asking about gas given off at the cathode. Here, the gas as it is aqueous sodium chloride, it means there is some molecule of water. At the cathode, the gas which will be produced, it is H2. This H2 came from water molecule which is in sodium chloride, because sodium plus is less reduced than what we see at cathode, gas we see at cathode is hydrogen from water molecule. For number B, state the product formed at anode. They are asking about product formed at anode. Remember, at anode, kuri anode hajyayo ion ziri charge negatively. While kuri cathode hajyayo ion ziri charge positively. Ubwo bivuze ngo the product tuzabona kuri anode tuzabona chlorine 2 gas. Kubera ko chlorine minus niza bagiye kuri anode, then ibe ize gutanga chlorine 2. Write the ionic equation for the reaction taking place at anode. We are going to write the ionic equation which produces this chlorine. As I said, at anode, kuri anode hajyayo ion ziri charge negatively. This means that we have chlorine minus ion izagenda igatanga chlorine 2, which is gas. Here, oxidation state chlorine, we all know if the minus. Let us first balance our chemical equation. Here we have 2 chlorine in the product. In the reactant, we should have also 2 chlorine. This means this chlorine has this has 0, while this has minus 2. This should gain 2 electrons. This should gain 2 electrons to be stable. Then we have this product. At anode, it is this reaction we will have. Then let's move to the next sub-question. Let us continue to sub-question number D. The concentrated sodium chloride is replaced in the apparatus with copper sulfate solution, which is also in aqueous. Give the product formed at anode. When we use for copper sulfate, when you use carbon as electrode, the product at anode we have OH minus, which oxidized to give oxygen gas at anode. So the product here it is oxygen gas. It is oxygen gas which produces, because here we have OH minus, here oxidized igatanga H2O plus oxygen. This OH minus is from the water in this aqueous copper sulfate. Also, for question, the next question, sub-question, write the ionic equation for the reaction taking place at the cathode. Here at the cathode, remember at the cathode, ion is positively charged, which is called cation, are the one which take place at cathode. Means for copper sulfate solution at cathode, when the electrode is carbon electrode, we have copper 2 plus, which will be reduced to copper. Then here we add on 2 electrons. This is the chemical equation which will take place at cathode. Let's move to the next question. Let's move to question number 10. Given the compound M and the N below, answer the question that follows. The compound given is this. This is M. This is compound N. Question number Question number 8. Give the common molecular formula of the M and the N. Here, if you see here, this molecular M has 1, 2, 3 carbon with 1 oxygen, and the oxygen is bonded on this carbon, which doesn't have any other hydrogen. For this means that this is a keton, and here we have also 1, 2, 3 carbon with 1 oxygen. This means the molecular formula of this compound can be C3, as carbon are 3. Then let's count about hydrogen. We have 1, 2, 3, 4, 5, 6 hydrogen. Even here we have 6 hydrogen, means C3H6, and we have 1 oxygen, which is like this. This is the common molecular formula for the compound M and the compound N. Number B, state the term used to mean the relationship between M and the N. As these have the same molecular formula, but they differ on how on the functional group. Here we have keton, as we have Ala, C double bond, Ala. Here we have aldehyde, as we have Ala, C double bond O. This is an aldehyde. This means that this is the relationship between those molecules is functional isomerism. We know at functional isomerism, they have the same molecular formula, but differ on the functional group. Here the functional group is keton, while here the functional group is aldehyde, while the molecular formula is the same. The answer is functional group, functional isomerism. For question number C, write down other 2 examples with 4 carbon atom. One related to M and the other related to N. Means it's like this one, but containing 4 carbons. We may say, for example, we may say C4. May say CH3, CH2, C double bond or CH3. I have 1, 2, 3, 4 carbon, and this is relating this with M, which is keton, relate with M. With M. Also, we may have one which relates with N, which may be CH3, CH2, CH2, C double bond or H. 1, 2, 3, 4 carbon. This is maybe a aldehyde for which can be related with this one with 4 carbon. Let's move to the next sub question. For number D, explain what should be observed. Observed when the Brady's reagent is reacted with M and the N. For Brady's reagent, keton react with Brady's reagent. When it reacts, we observe orange precipitate. This caused by that when increase of positively charged ion. Here for N twamaze kubona ko twabonye ko ari aldehyde. Also, we can observe orange precipitate. Also, this orange precipitate can be caused by reduction of negatively charged ions. That's what we can observe. Orange for M, we can observe orange precipitate. Caused by increase of positively charged ion for M, for N. Also we observe orange precipitate. This caused by reducing of negatively charged ions. Let's move to question number 11. Given the acetonitrile molecule, which is written chemically like this, consider the functional carbon. The functional carbon is this one, where nitrogen attached as C1, and the adjacent carbon as C2. The adjacent carbon is this one. Then question number 8. Predict the bond angle around functional carbon. Bond angle dusanga muri no functional carbon. As you see, we have like this. This is linear planar. This is linear planar because it is approximately. Let's use approximately. It is approximately 190 degrees. That is why it is linear planar. For number B, give the hybridization on both carbon atoms. Let's start from functional carbon, which is called C1. C1, it have hybridization, which is SP, because this carbon attached with only one nitrogen. Then we have also for adjacent carbon we have sp3 hybridization. For sub-question number C, determine the total number of sigma bond and P bond in acetonitrile. For sigma, we have how many sigma? Considering here, we have like 5. We have 3. We have 3 from CH. We have 5 sigma bond. 3 from CH. We have also 1 from CC, and we have then we have 1 from CN, which equal to 5 sigma bond. For pi bond, we have how many pi bonds? For pi bond, we can observe pi bond. We have a 2 pi bond. We have one from this triple bond, and you have the one from this carbon. Then you have two pi bond. Two pi bond from this CN, from this CN. Let's move to the next question. Let's move to question 12. Coordination compounds are dot geometry around the central metal atom or ion. Define the term coordination number in a complex. This coordination number in a complex is just a total number of atoms that attach on the central atom. Total number of ion or atoms that attach on the central atom. That is what we call coordination number. For number B, give the name or formula of the following complex compound. Here we have sodium, here we have copper, but this copper we guess it is coprat, then this is bromine. This bromine has 4, then you can say sodium, tetrabromo, picrat. Here we can give a formula because they have given name. Amine, aqua, chromium, iron, 3. Here, amine means you have 3 amine, aqua, chlorides aqua, Lattice water, 3. Then chromium iron. Draw the shape of the complex containing platinum 4 chlorides. Platinum 2 chlorides. This is a square platinum. This question, the research and development unit of a chemical compound is studying the reaction of methane and the hydrogen sulfate, 2 components of natural gas. The reaction is this. In one experiment, 2.0 mole of methane and 2.0 mole of hydrogen sulfide, 1.0 mole of hydrogen gas, and 1.0 mole of carbon sulfide are mixed in a 250 milliliter vessels at 96 degrees Celsius. At this temperature, Qc is equal to, equilibrium constant is equal to 0.036. Question number 8. Write the expression of Kc for the above equilibrium. You know, for Kc is equal to the concentration of the reactant, which is S2 or 4, 4 times 2. Here it is power 1 because here there is 1 that is this set, right? Then over product of concentration of reactant, which is CH4 times H2S power 2 because we have 2. For subtraction B, calculate the reaction quotient value for the experiment. It should be this for this. Reaction quotient which we tell us is CA equal to. Here, the concentration of hydrogen is 1. Here we have 0.1 more. We will have 0.1 more. It's 4. Then for also carbon sulfide we have 0.1. No 1. Sorry. 1.0 more. 1.0. Here also have 1.0. 0 more. Over. We have 2.0. Using 2.0. Here we have power. No. We have power. We have power 2. Using equal to. Here is D1. 1 over 8. 1 over 8 equals 1, 2, 5. This is the quotient value of this experiment. State at which side the equilibrium rise. As you see here, quotient value is less than 1. When it is less than 1. When it is less than 1, here the equilibrium rise forward, means toward the product. Because this percent is less than 1. Predict how the system will shift in order to attain the equilibrium. To attain the equilibrium, this should shift towards the reactant. This should shift towards the reactant. Okay. Let's continue with the next question. For question number 14. An isoelectric point, pH, Pi, is the pH at which an amino acid carries no net electrical charge in the statistical mean. Consider cysteine as an essential amino acid whose pKa1 and pKa2 are 1.96 and 8.18 respectively. The structure of cysteine is given below. This is the structure of cysteine. Give the major product formed when cysteine is reacted with sodium hydroxide. Here, the major product which will be formed are this amino acid group will react with sodium, then it will produce amino acid, it will produce cysteine sodium salt. Major product is sodium salt, where we have CH2 CSHC. This is minus, then this sodium plus will be attached here. For reaction with hydrochloric acid, they will be produced chloride salt. This will be the major product where this amino group will accept a proton ion. Then we have a compound like this, C3H8 chlorine NO2 NO2S. We have compound like this, which is chloride salt, as major product of this reaction. Determine the isoelectric point value pH of crystalline. As you know, to calculate isoelectric point value, we add on pK1 plus pKa2, then divided by 2. We get this isoelectric point value. This means that Pi will be equal pKa1 plus pKa2, then divided by 2, which will be equal to 1.96 plus 8 over 2. We get 5.7. This is the value of isoelectric point value. Let's move to the next question. The nature of substituents already present on the benzene ring determines the position of the next incoming group. Give the systematic IPAC name of benzene. The systematic IPAC name of the benzene, when you talk about benzene, it is like this only. Then we say IPAC name, it is like cyclo 1, 3, 5. This 1, 3, 5 hagarariye aho double bond ibifatiye muri benzene ring. When double bond ya mbere iri hano, then dusimbuka indi kaza hano 1, 3, then 5. Cyclotriene. For subquestion number B, identify the necessary condition X for the following reaction. The necessary condition here, the condition it is really just should be this is the necessary condition. For number 3, for each the following aromatic compound which substance group interfaced, give a reason for each of them. We'll answer. For the question 1, here we have NO2 and the methyl. This NO2 will come first because it is an electron withdrawing. It is a strong electron withdrawing. That is why here NO2 will come will enter first, because it is a strong electron withdrawing. Wait for this compound number B. This carboxylic acid group will enter first because it is good electron losing, proton losing. COOH enter first. Because it is good Then let's move to the next question. The first order reaction 2A produce B plus C. Take 30 minutes for 50% of the initial reactant to be consumed. This reaction follows the integrated rate law, which is this one. Define the term half-life. The term half-life, it is a time needed for a reaction to be to reach a time needed for concentration of a reactant to reach at a half of the concentration of the product. That is what you call half-life. Concentration of a reaction to be at a half of its initial concentration of the reactant. What is the half-life for the reaction above? The reaction we have here is this one, and they told us that the work of the first 30 minutes for 50%. Already 50% is a half, means it is just a half-life. This means that the half-life for this reaction, it is 30 minutes. Because at 30 minutes, 50% of the initial reactant yari yamaze kuba consumed. For number C, determine the rate constant K for reaction above. We are asked rate constant, which is equal to 1. We know for first order reaction, half-life, it is equal to ln of 2 over rate constant. This means that we can, according to this, we can obtain rate constant. Here we have rate constant, which will be equal to ln of 2 over ln of 2 over half-life. Half-life time we have here, it is just 30. It is equal to 30, we get by calculating here we will get, this is 0 point, we get 0.693, then over 30, which will give us 0.0231. This is the rate constant of this reaction. For number D, calculate the time required for 90% of the initial reactant to be to compression. Here, to reach at 90%, we have the integrated rate law. We have this one. We use this integrated rate law where we have Rn, which will be equal to minus Kt plus Rn A. Here, why we have 90%, we have concentration, which is 0 at 80. Concentration equal to 0.1. While at 90%, 80 will be 0.1. 80 will be 0.1. Then I0 will be 0 because we are at initial. Then replacing the value of each in this integrated rate law, we will get Ln of 0.1, which will be equal to minus Kt. We have given, we are asking time, and already calculated. Kt will be 0 minus 0.0231 times T plus Rn of here we get 0. Rn of 0 equal to 0. Then we remain with T, which will be equal to minus 0.0231 over Rn of 0.1. Calculating. Then T will be equal to T will be equal to 99.7 minutes. The time to reach at 90% will be 99.7 minutes. For some question A, one of the following statements is true while the other is false. Regarding the first order reduction to A, which produces B plus C. Identify the true statement and the false one. Give a short explanation for your reasoning. For us, ubwo tugiye kureba true or false n'impamvu. For a graph of A versus time is a straight line. This is false. This is false because the for first order reaction, the graph of concentration of A versus time, it is not a straight line. It is exponential. For double R, the rate of reaction is minus 1/2 the rate of the disappearance of A. This is true. This is true because this rate is approximately minus because during this reaction, 2A consumed per each reaction. Kuba 2 moles ziba consumed kuri each reaction, nibyo bizatuma this rate of reaction iba approximately minus. Let's move on with the question 17. This question concerns the chlorides of some element of the third period of the periodic table from sodium to phosphorus. The melting point of these chlorides are provided. Here for the first column, the second column. The first column are compound, the second is the melting point. Then there is bonding. Question number A. Copy and complete the row of bonding using the term ionic with covalence and covalent. Here, no need of copy, let's use this. Here, for sodium chloride, we'll put in ionic. This sodium chloride, it is ionic compound. For magnesium chloride, it is ionic with covalence. This magnesium compound may have some character of covalent. For chlorine, this is a covalent molecular. Covalent. Even for silicon chloride, it is a covalent. This also is covalent. And this is covalent. From aluminium, we have covalent moleculars. For question number B, give the equation with state symbols for the reaction of phosphorus with chlorine to form phosphorus chloride 5. Here we have phosphorus which is solid. This can react with chlorine 2, which is gas, to produce phosphorus 5, which can be written like this. Then, to balance the chemical equation here we have 5 chlorine. Here we have 1 phosphorus. Here we have 1, 2 chlorine. We have 5. To balance this chemical equation, you may put 2 here, This will be, then we put 5 here. This will be 10. 2, then we put 2 here. This should be the balanced equation of this reaction of phosphorus or phosphorus with chloride from phosphorus 5 chlorides. Let's move on with the next sub question. Here, explain why melting point of magnesium chloride is lower than the melting point of sodium chloride. This melting point is, according to the table we saw, melting point of magnesium chloride is less than of this one, because for magnesium chloride, remember we find that magnesium chloride is ionic covalence. Presence of that covalent caused lower lattice energy, which caused pH to be reduced. Then the melting point of magnesium chloride become lower than the melting point of sodium chloride. Lattice. For sub-question number D, the chloride of sodium and aluminium dissolved in water according to the following equation. For sodium chloride in water, the product is sodium ion chloride ion. For aluminium chloride, the product is this one. For sub-question I, choose the correct answer and justify your reasoning. The solution of sodium chloride has a pH which is A, less than 7, B, equal to 7, C, greater than 7, D, equal to 10. The correct answer is number B. It is equal to 7, because this sodium chloride, it is solved from strong base and strong acid. That's why the pH is equal to 7. The correct answer is number B. For sub-question double E, choose a correct answer and justify your reasoning. The solution of aluminium chloride is A, amphoteric, B, basic, C, neutral, D, acidic. The correct answer is D, because reason why, as you see here, aluminium chloride dissociates in water to liberate this H3O plus, which is indicate that this solution it is acidic. Then let's move on to the question number 18. F and G belong in the product of the polymerization reaction. The first polymer is this one, the second polymer is this. Write the structure formula of the monomers of F and G. For F, the structure formula, as you see, the repeating unit, when I choose the repeating unit here, the repeating unit is this, up to here, then this and this. Means that the repeating unit or structure formula of monomer is C H 2 CH2 prime. CH2 vanilla chlorides. For G, we have two monomers. The first monomer is OH, CH2, OH, and C, C6H4, C, OH. Give the name of constituent monomers of F and G. Here for F, we have, it is vinyl chloride. While for G, as we saw, we have two monomers. First monomer is graphite acid and glycol and glycol. Let's move to next step, substitution. So the repeating unit of polymer F and G. As we saw for F, we saw that we have C, we have C, H, C, chloride, H, then we do like this, then N. For G, we saw that for D we have two polymers. Repeating unit we have CH2, or C6H4. And we have two polymers. The first one is methionine, then this one, which is the phthalic acid, then the repeating unit will be this and this. This N stands for the number of monomer we have. For number D, suggest any two applications of polymer F. As we saw, polymer F is vinyl chloride. This vinyl chloride used the first for manufacture of polymers. Ari agaciro tugomba dukoresha abakozi muri vinyl chloride of glucose and fittings. Also, these vinyl chlorides may be used as insulator for electrical wires. Used as insulator for electric wires. Which of 4G was formed through condensation polymerization? Support your answer. Here, for condensation polymerization, we have two different monomers which linked together to produce other small molecules, part of polymer. Here, for these monomers, there was a production of there was a release of water molecule. That's why G is a condensation polymerization. Because its reaction, its formation release a simple molecule which is water. For question 19, the following diagram shows the Bohr circle of crystal lattice of cesium chlorides. The interchange value, which is DH, provided are in kilojoule per mole. We have given the interchange. Question number 8, define the term lattice energy. When we talk about lattice energy, it is just when one molecule of ionic compound formed from its gaseous ion. When of ionic compound formed from its gaseous ion under standard condition. This is what we call lattice energy. One mole of ionic compound can be formed from its gaseous ion. For question number B, from the diagram above, identify the interchange I for formation of cesium chloride. This interchange should be called formation enthalpy. This enthalpy where cesium chloride formed, you can find it right here. Here we have cesium solid plus chlorine gas, which form cesium chloride. Then it is equal to minus, which is equal to minus, which is equal to minus 433 kilojoule per mole. First ionization of sodium, of cesium. For the first ionization of cesium, this is called ionization. Ionization enthalpy. Here, let's see about ionization of cesium. This cesium ionized, as you see here, we have sodium, which ionized cesium, which is gas, which is ionized, sorry, here. This sodium gas reacts with chlorine to be ionized to sodium ion. This is the first. Here we have first ionization. Here we have the second ionization. For the first ionization of cesium, we have the 3 enthalpy change, which is 376 plus 376 kilojoule per mole. As you see here, we have cesium gas, which ionized, first ionization, ionized to produce this. The enthalpy change used to ionize for the first ionization is this, for the second is this. Enthalpy change for the first electroaffinity of chlorine. For the first electroaffinity of chlorine is just here. First electroaffinity enthalpy change is this one. We have enthalpy change of minus 674 kilojoule per mole. It is called affinity enthalpy, and it is equal to minus 364 kilojoule per mole. So let's move to the next sub-question. For the calculating value of the lattice energy for DH6, according to Haber process, this DH6 equal to enthalpy will be equal to DH1, which is the enthalpy change of formation of this chlorine gas minus this enthalpy change of formation of first ionization, which is DH4 plus the entropy of formation of chlorine. This formation of chlorine gas, it is just the ratio of cesium gas and the chlorine gas, it is just a half. Means we may add this a half of 1/79, then plus, we start from here, then we go here, then plus the entropy change of first ionization of cesium, which is DH3 plus here the enthalpy change of formation of the formation of CS3 equal to, here we have at initial state, and the enthalpy change igomba kuba ikiri 0, then we add on 0, then plus DH5. Here we get DH6, which will be equal to here we get minus this is minus 4, 3, A minus 1, GH4 equal to 1, then plus 1 over 2, 79, plus 0 plus 1 over 2, this enthalpy change from here, from first ionization, because here the ratio of cesium and chloride gas is a half. Then it is 3, 7, 6, which will be equal to minus 363 kilojoule per mole. By calculation, we saw this. Means DH of formation of cesium chloride will be equal to minus 373 kilojoule per mole according to Bohr-Haber process or cycle. Let's move on with the next question. Now, let's move on to our last question. This question relates to acid-base indicator and titration curves. As methyl orange is an acid-base indicator commonly used in certain acid-base titration. The equilibrium dissociation of the methyl orange is shown below, which is like this. Using the Le Chatelier principle, the equilibrium above predict what happened when some drops of methyl orange are added on sodium on the solution of hydrochloric acid. Here, when some drops of methyl orange added on solution of hydrochloric acid, it will turn to red. The reason why it will turn to red, it is because of increase of H3O plus. The proton will be increased in the solution, then the solution turns to red. For the above is when some drops of methyl orange added on the solution of sodium hydroxide. Here, it will turn to yellow. To yellow. We observe yellow color. This is because here, when some drops of methyl orange added to the solution of sodium hydroxide, Here, there will be the decrease. There will be the decrease. Ukuvuga ngo proton, number of proton zizagabanuka muri solution. Of decrease of H3O plus in the solution. That's why it will turn to yellow color. Number B, determine the pH range of methyl orange given that its pKi equal to 3. Here, we know that pH equal to presumably P equal to pKi presumably 1. This means pH should vary between pKi plus presumably 1. This it will give us, we'll have pH which will vary from 3 presumably 1. This means pH will vary from when we take 3 minus 1 will be 2, from 2 to 3 plus 1 to 4. Means pH of methyl orange vary from 2 to 4. Let's move to the last sub question of this question 20. This sub question, we have asked to plot the titration curve of pH versus volume data. Here we have given the volume of sodium hydroxide added in milliliter and pH of solution in the hydrated solution. Let us plot the graph. Here, as you can see in our data, the endpoint will be should be at 20 milliliter. As at 20 milliliter, it is the weather pH is equal to 7. And you know that for us the best titration, we reach at the endpoint at pH which is equal to 7, which is neutral. On the y-axis situation we have pH. On the x-axis we should have volume in milliliter. According to our data, before adding any volume of sodium hydroxide, pH was 1. Here we have, we should graduate from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then here also should graduate 2, 4, 6, 8, 10, 12, 14, 15, 16, 22, 23, 24, 26, 28, 30, 32, 34, 36. We start from here. Then, why is 0 milliliter of sodium before adding sodium hydroxide? pH was 1. This means we start from here. For 2.0 milliliter, pH was 1.09. Let's see. Here for 2, it's around here. Adding 5 milliliter, the pH was 1.22. This is so that then 1.2. Adding 10 milliliter, 1.8, pH was 1.48. Adding 10 milliliter, 10 milliliter here, just 1.40, 1.48. Adding 15 milliliter, we get at 1.85 pH. 15 degrees somewhere here. Then pH, it is just around 2. Adding 15, adding 18, the pH becomes 2.30, 18 is here, then pH is here. No kongeramo mililitiro 18 pH, bayisiba 2.30. 2.30 is somewhere here. Adding and 3.9, pH becomes 3.16. 3.9 is here about 20. Adding 20, the pH becomes 7. Remember here it is at the end point. Then we get 20. The pH will be 7, 30, 20. Then, reaching to 20.1, the pH becomes 10.40. 10.40. Here I have 10. 20.1 is somewhere nearby 20. Then the pH becomes 10.14 is about half here. Adding 21.0, the pH becomes 11.38. 21.0, here is the half here. Then here it is 11. Then the pH becomes 11.38. Then 11.38 is somewhere here by half. Then we will get, which was 20.21, is 0, is 0 here. Then adding 25.0 milliliter, the pH becomes 12. 25 is just here. It will become 12.20. Adding 35.5 is like here. The pH became 12.40, 12.43. It is somewhere half here anyway. Then this is how the curve is working. Remember here it is at the end point. This is how the curve of. So, guys, thank you for following us. Mu gihe twakosoraga ino chemistry national exam y'umwaka wa 2023-2024, reka mbarangire kuza kudukurikirana dukosora ibizami bitandukanye. Ndibutse ko dukosora ibizami kuva muri P6 kugera muri senior 6 ndetse mu masomo ayo ari yo yose. Mukomeze kudukurikirana kuri YouTube channel yacu Power Academy, kandi comments zanyu zirakenewe kugira ngo tumenye ibyo tubagezaho, tumenye icyo twumvinga, icyo twongeraho mu byo mukeneye, kandi tubararikira no gukora subscribe kugira ngo atazagira national exam igucika mu gihe iri gukosora. Ubwo reka dukomeze tubane, kandi mwari kumwe na teacher Washimi Anastasie, nakagaruka kuri Power Academy. Murakoze cyane.
Naimburi kumera cameraman mkuu. Ndio kuti waje kuomba.